Hey, good morning, everybody. Looks like we're going to be e-learning for a couple of weeks now. I know with the change in schedules and just the uncertainty of things have really caused a lot of anxiety and stress in our lives lately. Definitely mine, I can admit that. Maybe I've weighed it around the classroom, and I apologize if it has affected your mood, but I really just want us to be able to power through this and know that it's okay to feel a certain way. But it's also important to kind of talk about those things too, so it doesn't really you know, get you deep down and drive you crazy a little bit. But anyways, moving forward in these next 2 weeks, I'm going to try to make these videos as short and sweet as possible because, again, we only have about 40-minute class periods. So with this one, we're just going to power through it, and hopefully this is a nice quick video. This is the last congruence theorem that we need to look at when dealing with triangles. So this lesson 5 deals with HL congruence. That stands for hypotenuse leg. We're going to use that to determine if triangles are congruent, and then we're going to do a quick just run through like mixed review of how these SSS, SAS, ASA, and AAS are used to basically solve problems. One thing that I'll mention too is I'm going to put this reference sheet on Schoology, and I have it completely filled in. So as you work through the rest of this unit, if we complete it online in Schoology, make sure you're referencing this bad boy because it can be pretty helpful. All right. So again, we basically talked about in the last couple of lessons of like how do you know when two triangles are congruent when you have limited information. So these are the theorems that are used to prove if triangles are congruent or not. We've already touched on basically 3 pairs of sides are congruent, 2 pairs of sides and an angle in between, so SAS. The last lesson was ASA and AAS. And then this lesson, the last one is just HL. This one's actually super easy because you can only have HL congruency if there's right triangles. So that can be kind of a clue here as far as identifying them. So on your reference sheet here, we have this last theorem, congruence theorem, that is HL, hypotenuse leg theorem. Basically says that when you have a right triangle and you know the hypotenuses are the same, the hypotenuse in a right triangle is always opposite the right angle. And it's always the longest side. So the hypotenuse is opposite the right angle. It's the longest side. If you know the hypotenuses are the same in both triangles, usually implied by the markings here, and you know basically any one leg, so that means basically any other side. So if you know any other side is congruent, then the triangles are congruent. So the steps here, if you're trying to check for HL congruency, is they need to be right triangles. The hypotenuses need to be the same, and then you just need any other side to be the same. That's all we're looking for here. So let's run through an example. So first things first, notice how we have right triangles because of the right angles here. So that means that each of these are right triangles. Notice how this shared side in both triangles is actually the hypotenuse, because if you pulled these triangles apart, this longest side right here would be the same in both triangles, and that's called the hypotenuse. So the hypotenuses are the same. So that gets the H part of our HL congruency theorem. And then also notice how they tell you that these sides are also congruent. So that's also going to be the L part in our HL congruency, because you just need one other pair of sides congruent here. So we would say the triangles are congruent by HL congruence. One other example here. Actually, we're going to run through these 6 examples. So this would be if you don't know, or if maybe you haven't been watching the videos very thoroughly over the past couple of weeks, or over the last week or so, we're going to run through these mixed practice examples, and hopefully in doing these examples, you should be able to basically get the gist of everything we've done in the last week and a half or so. All right, so what we're going to do is take a look at each problem and determine if it's SSS, SAS, ASA, AAS, or HL congruence. So for number 1 here, notice how these 2 triangles, they share a common side. So we would be able to say that that shared side is congruent to itself. And then we would have 1 pair of congruent sides, 2 pairs of congruent sides, and then this 3rd pair of sides, if you pull those triangles apart, would also be the same. So we have side, side, side congruency there. Number 2 is what we just went through. Notice how they're right triangles, so we have our right angles here. We also have these long sides, the hypotenuses are the same, so we have the H part. And then we have one other side, which is called the leg in a triangle, so this would be your HL congruency for that one. Number three, we have these pairs of sides are given to us as congruent. These pair of sides, so we got two pairs of sides, and we got no other information. The only other information that you should be able to notice from this diagram is that when these two straight lines intersect, these angles on either side are going to be vertical angles. So these vertical angles have to be the same. Now, if angles are congruent, you can use the little arc marks to mark them congruent. So that's enough to then say we have our side here, angle, and then another side, and we have side, angle, side. So this would be your side, angle, side congruence here. All right, number 4, this is typically going to be the trickier ones when you're dealing with parallel lines, because we have to be able to think back to the last unit where we're dealing with alternate interior angles, corresponding angles, and all those. So in here, because these lines are parallel that have the one arrow on it, we have corresponding angles, meaning that these angles here, because these lines are parallel, this is a transversal that cuts all the way through here, these angles would be corresponding. And then also, because these lines that have the double arrows on there are also parallel, that would mean that these angles are also corresponding here. So we would be able to say that those angles are, those two different angle pairs are congruent. So then we would have angle, side, angle, or angle, side, angle congruence. So it would be ASA for that one. Again, if these weren't making sense, just rewind them and rewatch them because you should be able to kind of get the gist of basically just working through these examples. All right, number 5 here. So again, we're basically looking at these two triangles to trying to determine if they're congruent or not. This little piece of information helps. This is something that people were struggling with on the proofs or just kind of making sense of what this means. If it says BC bisects angle ABD, they're saying that this line BC, which is this line right here in the diagram, bisect means it cuts it right in half. So if it bisects this angle ABD, it's basically saying that they're taking this whole angle ABD and they're going to slice it right in half where BC intersects it. So what it means is that these two angles are cut into two equal parts. So we have these two angles are congruent to each other. That's what this statement means for us. So that means angle ABC is the same as angle DBC. Now, one thing that you should also be able to notice is that in this diagram, BC is a shared side. So it's going to be the same in both. So that is a shared side. So then if you kind of look through here, we have side AB is congruent to side DB. We have these angles are, we have this other side is congruent to itself. And that is the reflexive property if you're saying something's congruent to itself. So we have those two sides, and then we have the angle in between these two sides. So it's side, angle, side, side, angle, side. Also pay attention to the order of the letters. So angle ABC would be ABC is this angle right here, and DBC is this angle right here. So this would be side, angle, side congruence. And we would be able to actually write a congruency statement here because we have the letters on the triangles. So we could say triangle ABC is congruent to triangle DBC by SAS congruence. This is something that you kind of just want to be aware of as you kind of move forward, basically preparing for the test and whatnot. All right, last example here. So this one, we're given this little statement right here says that JK is parallel to MN. So first off, mark the parallelism can sometimes help. I would also recommend drawing these diagrams if you're trying to make sense of them. So in this one, we have those lines are parallel. If parallel lines exist, we have alternate interior angles. So these two angles right here are on opposite sides of this transversal JN. So they're alternate. And then they're in between the parallel lines. So these are alternate interior angles. And we would also have alternate interior angles here as well. So this would be angle, side, angle, angle, side, angle. Because we have this side JK is congruent to this side MN. It was marked here for us prior. So again, those angles are congruent. KJL would be this angle. MNL is this angle right here. So we have angle, side, angle congruence here. So we'd be able to make this statement that these triangles are congruent. One other thing that you could notice here, though, is that there's actually another way that we could prove these triangles are congruent because of the vertical angles here. So if these angles are vertical angles, we can say that they're congruent to each other, which then allows us to say that angle, angle, side actually works here too. So there's actually two different answers that will work for this problem. You're going to run into problems on the assignment that are kind of similar to this too, where there's actually two answers to these problems. All right. And then this lesson 5 assignment is on Schoology. I'm making it a completion grade. You have to get at least a 3 out of 5 on the assignment in order to get credit. One thing I will say is that if you need help, make sure that you're asked for it. Try to schedule a Zoom with me. Since we're going to be e-learning for the next couple of weeks, we should be able to set up some times throughout the school day to check in, and I can help you complete any assignments that you need help with. All right. Again, just try to stay positive. If things are getting you down, then find ways to kind of relieve some stress. But if you do need to speak to somebody, you can always reach out to me or really anybody at the school here. Really want to just reinforce that. So hopefully everything goes well here, and hope you have a great day. Thanks.